All right, this is Miss Mills. I'm going to talk about 4.1. So we're starting Chapter 4, Equations and Inequalities, and 4.1 is a task called Cafeteria Actions and Reactions. And in class, we read and noticed things about this, and we ended up figuring out the answer to this question about how many trays there were in each of the cartons. Okay, so what Elvira did is she passed out 24 trays, and then she said, oh, I want to split them up between the 3 lines, and there were 12 in each line. So there's different ways to figure that out, but this would be one way of noting what you're doing. And when we worked that out, we got 24 plus 36, so that was 60 trays. And, sorry, 60. That was 60 trays. And there were 4 cartons. So if we want to know in each carton, we would divide by 4 cartons. And we would end up with 5. We decided? No, 15. Sorry, 15. Put that where you could see it. 15 trays per carton. Okay, so that was our first little puzzle. Now it's getting way more complicated. So Elvira's standing around watching the kids, and she wants to figure out how many kids are sitting at the front table for some reason. So she takes some information down, but she forgot to write the number because she got distracted. And you can imagine in a cafeteria what kind of things could distract her. Somebody probably threw their milk or something. So she didn't know how many kids were sitting there. So as I go through these, what I'm going to do with you guys right now, I'm going to use a different color, is I'm just going to note the abstract algebra that could be used for each step. So when you have a number and you don't know what it is, that's the definition of a variable. Okay, so that's our variable. And then she noticed some things happening. So however many kids there were, each one suddenly got joined by a friend. And so it doubled. Well, double is multiplied by 2. So now it's 2x. All right, and then 4 more came along. So we just take the, we don't know what this number is, but it is a real number. We just don't know what it is yet. So we just call it 2x. And 4 more came along. So add 4. 4 more is adding. So now we have a new expression for how many kids are at the table. So let's just imagine there were 5 kids at the table. Then it doubled, 2 times 5, then there's 10 kids at the table. Then 4 more added. 10 plus 4 is 14. That works. 2 times 5 is 10, plus 4 is 14. All right, she noticed some other things that happened. The students at the front table separated into 3 equal-sized groups. So when you're separating into 3, that's a division problem. And then 2 groups left, leaving only 1/3 of the students at the table. So there's 3 equal groups and only one of them stayed. So we take what we had over here, 2x plus 4, could be any number, but we could describe it as 2x plus 4. We have to divide it into 3 equal groups. And then at the end, she's not distracted and she can count them, and there's 12 at the end. So now she's wondering, because she's good at wondering, how many students were sitting at the front table when she wrote her first note. Unfortunately, she's not sure what order the middle 3 post-it notes were recorded in, since they got stuck together in random order. She's wondering if it matters. Okay, well, so let's just figure out using this order. Let's work backwards and let's figure out what happened here. So at the very end there were 12. We know that. Before that, there were 3 equal-sized groups, and each one had 12. 3 times 12 is 36. So at that point, there were 36 kids before they separated. All right? Now, before that happened, four kids got added. So to undo addition, we do subtraction. So there were 36 kids after 4 got added. So before that, there was 32. So I'm going to check. 32 plus 4 does make 36. So I did that right. Now, before that, there were half as many. So we're dividing by 2. Well, half of 32 is 16. So I'm going to say x equals 16, and then I'm going to check my work. Double, we're just going to not use the equation, we're just going to use the words. If I double 16, I get 32. If I add 4, I get 36. If I divide by 3, I get 12, and that's what I was supposed to get. So we solved that puzzle. The answer is 16. So originally, where is that? Originally, there were 16 kids at that table. Must be a pretty big table. So there were 16. And now we're going to solve this little puzzle. What if I change the order? We're going to do that on a different video.